Welcome to Classless Addressing. So what is classless addressing? Classless addressing is the process of grouping IPv4 addresses into various network groups based on a variable subnet mask with host and network portions and not based on the first octet. With classless addressing, we can move our network portions to wherever we want. The subnet mask is what determines which part of the IPv4 address is the network portion and which part is the host portion. So basically we have examples here of IPv4 addresses that have a variable subnet mask. So remember when we talked about classful addressing, we said that we usually have fixed classes which are defined by having all ones in certain octets. But this time we have it different such that you can actually have ones and zeros within the same octet in the subnet mask. So instead of having the normal 8, 16, 24, and 32 as subnet mask notations for the classful addressing, here we have different other numbers we can use for the subnet mask notation. Like in this example, we have 10, we have 19, we have 26, we have 17, and we have 6. So this means that the first 10 bits are the network portions of the IP address. 10 bits is the first 8 bits for the first octet and 2 bits entering into the second octet. And the same with 19 bits, we have the first 16 bits which covers the first and second octet, and we have 3 extra bits that enter into the third octet. So we can see that the classless addressing is very different from the classful addressing because you have liberty to define exactly where you want your network portions. The network portions cross in between the octets. It's not statically assigned per octet. So in this example, we can see that we don't have just 255 and zeros, but we have 255 for the first octet and we have 192 for the second octet. So how did we get 192? So remember our IP addressing table, and we said that each of these columns represent each bit. The 128 representing the first bit of the octet and the 1 representing the last bit of the octet. We also realize that moving from left to right, we add up the bits that are turned on. That means they are ones. So in this case here, we have 10, which means that the first octet is all ones because that's the first 8 bit is all ones. And that's how we got 255, because when you add, we have 1 here, so 128 plus, we have another one 64 plus another one 32 plus another one 16 plus 8 plus 4 plus 2 plus 1, we'll get 255. But in the second case, we have the remaining 2 bits from these 10 bits assigned to the second octet, and it means the first bit is 128 and the second bit, which is the 10th bit of that IP address, is 64. So if you add 128 plus 64, you will get 192. And that's how we got this 192 here. And in the same way, if you come down to this IP address 210.10.5.2, we have a subnet mask here giving us /19 subnet mask notation. So what does it mean? It means that the first 2 octets, which each take 8 bits, that makes it 16 in total, are all ones. So that's why we have 255 for the first octet and 255 for the second octet. So if you take 16, which is 88, from 19, what we are left with is 3. And that 3 makes up the third octet. So in the same way, we come down here and we assume that this is our third octet. And we start from the first position, and we can see it's 128, and we go to the second one, which is 64, and the third one, which is 32. So these are the 3 bits that are in the third octet, making up the network portion. So when we add 128 plus 64 plus 32, what do we get? We get 224. We also use the same method to consider these IP addresses down here. And that's basically how to define classless IP addresses. So this is an example of a classless IP address. We can see that we have the host and network portions cutting across the third octet. The first octet, which is all ones, the second octet, which is all ones, is also part of the network portion, and the third octet, which has the first 4 bits as all ones and the remaining 4 bits as 0, forms partial network portions and host portions. So we can see that we have the first 4 bits turned on for the third octet. And using our table, if we to consider what the subnet mask will look like, we'll have to consider the first 4 bits. So we'll say 128 plus 64 plus 32 plus 16, and that will give us 240. So that's how we got this subnet mask. And what will our subnet mask notation be? Because we have the first 16 bits turned on for the 2 octets and the remaining 4 bits also turned on, if we add the 16 to 4, we'll get /20. So our subnet mask notation for this IP address will be /20.